awkward enough that it was ready to time to move on. Where you going, Chris? Okay, we want to get rid of this exponent, right? So here's what I would recommend doing. Think of that as two separate exponents. This is cubing it, right? So what would you do to get rid of cubing something? A square root doesn't cancel a cubing, but a cube root would, wouldn't it? So if I took the cube root of both sides, that's a good start. So I have x plus 3 in parentheses, still raised to now the 1/2 power equals, over here the cube root of 8 is 2. And now that it's raised to the 1/2 power, what does that really mean? That's a square root, right? And since that's a square root, is this a radical equation essentially? Sure. This is a radical equation. This is the same thing as saying the square root of x plus 3. Which means what? When we solve? Well, yeah, we're going to square both sides, and we're going to solve, but when we get that solution, you'll have to check it. No, I don't need plus or minus here. It was the double standard. If I had this, let's say if I had that, I need plus or minus this way. But when I square to get rid of the square root, I don't need plus or minus, but what I do need to do is I need to check.
You're not squaring the 2?
You take it to the second power.
Yeah, I'm squaring both sides. I'm squaring the 2, yes. I was like, what 2 is she talking about?
What is it saying? You have 2 underneath it, and it's still supposed to be, oh, okay, there you go. I'm
Yeah.
sorry.
Yeah, I'm going to square both sides,
Yeah.
whichever way I write it. But because it's a radical equation, remember, there may be extra solutions that aren't really solutions, and you have to check.
Okay.
That's what I was getting at. So x plus 3 equals 4. So what's x? And if we check it, 1 plus 3 is 4. And if I use my calculator and I take 4 and I raise it to the 3/2 power, you verify, do you get 8? And you do actually get 8, but you don't know that for a fact until you check it. So x equals 1 is my solution.
Here was 8, because that's what I was absent on longer.
Well, it's a terrible day to be absent. That's good, John. I'm sure you're not the only one that may have had trouble with 8. So let's do the log, solve the log of 2x minus the log of x minus 2 equals 1. That's a log equation, and there were two kinds of log equations, right? There was log equals log and log equals number. And which one do you think we're ultimately going to turn this into? Do you see logs on both sides? Now this is going to be log equals number, but it's not log equals number yet because it's log minus log. But that's not a big deal, right? I can combine those two logs together as a single log doing what?
Dividing 2x over x minus 2. The log of 2x over
Yeah, dividing their insides. So it's the log of 2x over x minus 2 equals 1. That was one of those 3 main properties. Yeah, we condensed it.
Okay.
Yeah, we condensed these two logs as a single log.
If it was addition, you just put out the same line.
Yeah, you multiply them. If it's log plus log, multiply their insides, and since it was log minus log, divide their insides. Now this is the log of something equals a number, right? And our strategy was to rewrite this in exponential form, and I always started with my base. What's my base for this log? It's an unwritten 10. This is the common log. This is understood base 10, right? So this is 10. And what's my exponent?
1.
1. Over here, the log equals the exponent. So 10 to the first power equals the leftover, the inside stuff. And since I'm kind of lazy, let's go ahead and knock this out. What is 10 to the first power? Okay. Now what? That's a rational equation, right? So when you have fractions and you're trying to solve an equation, you should, yeah, clear fractions, multiply by whatever you're dividing by. 2x over there equals, when I distribute, 10x minus 20. Oh, no, let's not do that. Let's do that. So negative 20 equals negative 8x. So x is positive, what? 5 over 2? Maybe. Why is it only a maybe? I have to check it. Why do I have to check it? These are all wonderful answers.
Cube rooting or square rooting?
No. It's a log equation.
Oh, the log equation.
Yeah. You have to check radical equations and you have to check log equations. Those are the two kinds of equations that might have had, that might have had extra solutions. But when we check log equations, remember, we only need to make sure we're not taking the log of 0 and we're not taking the log of a negative number. Otherwise, it should be cool. All right? So if I take 5 over 2, plug it into the first log, that's going to be positive, isn't it? 2 times positive, 5 over 2 is positive. In fact, it's 5. So that's fine. If I take 5 over 2 and subtract 2 from it, is that positive?
Yes. This 2 goes in 2.5, so 2.5 minus.
Yeah, this is 2.5 as a decimal, right? 2.5 minus 2, that's still positive 0.5. So it just squeaks by. So 5 over 2 it is. Hmm?